When cache is full, we need some mechanism to replace the data in the cache. So for this lecture, let's learn what happens when the direct map cache is full. In direct mapping, for every block there is a line number. And to find the line number, we have a formula. The formula is line number equals block number modulus number of lines. To understand this, let me take an example. Here I have main memory with 16 blocks and cache memory with 4 lines. And from the formula, I can write block number modulus number of lines is equal to the line number. So let's try one. Let's assume block number 3. So here the block number is 3. Now we need to take the modulus with number of lines, and here we have number of lines as 4. So 3 mod 4 is 3. Therefore it will be placed in cache line 3. What about block 14? So 14 mod number of lines is 4. So 14 mod 4 is 2. Therefore block 14 will be placed in cache line 2. This is the line position. I hope you are able to make out. Now let's understand what will happen if this whole cache is full. Now for this, let me take one example. Consider a 4 block cache memory with the following main memory block references. Assume cache is initially empty, and here are the references. Identify the hit ratio if the mapping is direct. Now to solve this, it's always a good practice to write the requests separately. So let me write it down. So here are the given requests, and then they mention that the cache memory size is 4 blocks. So let me draw the diagram. Okay, here we have the cache. Now let's fill the cache with the following memory requests, and we already know the formula. Block number modulus number of lines is equal to the line number. Now let's take the first request, that is 5. So 5 modulus number of lines is 4. So 5 mod 4, it is 1. Therefore this 5 has to be placed in line number 1. Now initially this is empty, therefore this is a miss. Now let's go to the second one. 4 modulus number of lines is 4. This is 0. Therefore 4 has to be placed in line 0. So 4 will come over here. Again initially this is empty, therefore this is a miss. Now how about 6? 6 will be placed in line number 2. This again is a miss. And 3 will be in line 3, therefore miss. Now look at 4. 4 is present in the cache, therefore this is a hit. Now how about 0? 0 has to be placed in line 0, but here already it is filled with 4. Therefore this will be replaced and we'll have 0 over here. Now because it is not there, this is basically a miss. Now 2, it has to go into line number 2, but here 6 is there, so this will be replaced with 2. So again miss. Then 5. Now 5 is available in the cache, therefore this is a hit. Then 3. 3 is also available in the cache, therefore this is a hit. Then 0 is also available, therefore it is a hit. Now how about 6? Now 6 is not there, it has to be in line number 2, so therefore this 2 will be replaced with 6, therefore this is a miss. 7 has to be in line 3, this is again a miss. Now 11 also has to be in line 3, so this is a miss. 3 also has to be here in line 3, and the last is 5. Now 5 is available, therefore this is a hit. The question asked is to calculate the hit ratio, so let's write the formula. Hit ratio is number of hits by number of attempts. In this example we can clearly see 1, 2, 3, 4, 5. 5 hits are there, and the total requests are 15. Therefore hit ratio is 1/3. Now here one point to note, any request which is coming to the processor, basically it calculates the line number using this particular formula, and then it checks the cache if some data is there. If it is not there, it will place it into it, something like this. Okay, let's take few more examples to understand this. Here is a question asked in GATE 2007. Consider a direct mapped cache with 8 cache blocks numbered 0 to 7. If the memory block requests are in the following order, these are the requests, which of the following memory blocks will not be in the cache at the end of the sequence? Alright, for this let me draw the diagram. Let's assume this is a cache with 8 blocks. These are the blocks. Let me also write the request. Now let's fill the cache with the following request. First is 3. 3 will be in line 3. Then 5. Then 2. 8. 0. Now 0 has to be in line 0, but 8 is there. So this will be replaced with 0. Then 63 will be in line 7. Then 9. Again 16 belongs to line 0, but here 0 is there. So this will be replaced with 16. Then 20 to line 4. Then 17 has to be in line 1, so this will be replaced with 17. Then 25 again line 1. Then 18 to line 2. Then 30 will be in line 6. 24 line 0. Then 2, it was there in line 2, but now it is 18, so again we'll replace it with 2. Then 63 is already there. Then 5 is already there. Then 82 will be over here. Then 17 over here. 24 is already there. Now look at the question. They're saying which of the following memory blocks will not be in the cache. Therefore look at the option. Option A is 3. 3 is there. 18 is actually not there, it is cancelled. 20 is there. 30 is there. Therefore option B is the answer. Now here one more thing, you need not write each and every request in the diagram. The better way is look at the options, pick up the numbers and circle them wherever they are. So 3 is over here, then 18 is somewhere over here, 20, then 30. Now as you proceed placing the numbers, as you move forward, as you cross this point, if you see any of the numbers is cancelled, that means that is the one which is not there. Therefore you can reduce the number of steps to some extent.